All right, let's use implicit differentiation to find this derivative with respect to x. So I think the easiest way to get going on this problem is going to be get rid of our fraction. I don't really want to deal with a fraction. So let's go ahead and multiply by our denominator to get started. So just move it to the other side. So we're going to multiply by cosine of y plus x. And the same thing on the right-hand side, cosine of y plus x. On the left-hand side, multiplying and dividing, same thing, numerator and denominator. It's going to kind of go away or make a 1. We're going to be left with sine of x plus y on the left-hand side. And because we just have a 1 on the right-hand side being multiplied, we really just get cosine of y plus x on the right-hand side. Distribute the 1 if you'd like to think about it that way. All right, now let's kind of go one term at a time and think about how do we take this derivative with respect to x. All right, the first one, we have a sine of x. Its derivative is going to be negative cosine of x. And because the variable there was an x, we don't need a dy dx over next to it. We could put a dx dx, but that doesn't really help us. Next up, let's move on to the y. We have the derivative of y is going to be a 1. Because our variable was y, we need to put a dy dx or a y prime as an equivalent, different notation to go with that. Next, on the right-hand side, looking at cosine of y, well, the derivative of cosine is going to be sine of y, but because our variable is y, don't forget the dy dx to go next to it. And finally, we have that x. Its derivative is going to be 1. Again, variable being x, we don't need the dy dx. All right, next, what I'm going to do is go ahead and just rearrange this. The end goal is get all the terms that have dy dx's on one side, all the terms that don't to the other side. All right, it doesn't really matter which direction you move things around. I'm going to go ahead and choose to move that cosine of x to the right-hand side by adding it. Okay, so on the left-hand side, negative cosine of x plus cosine of x kind of goes away. We are going to have 1 dy dx still left over here. And I'm really trying to take my time and go through this so I don't lose anyone as we're going. Really just rearranging our equation. So I'm bringing along on the right-hand side the sine of y, dy dx, plus 1 plus cosine of x. All right, next I'm going to go ahead and move that sine of y dx to the other side, so I'm going to subtract it. Don't forget your dy dx. Minus sine of y, dy dx. Okay, so on the left-hand side, we are left with 1 dy dx minus sine of y, dy dx. And on the right-hand side, we still have, after we've eliminated these, we still have 1 plus cosine of x. All right, well, we're almost there. What still remains is we have now both those terms on the left-hand side both have a dy dx. So what I'm going to do is go ahead and factor out that common factor. So that's going to leave us with a 1 minus sine of y inside a big set of parentheses is equal to 1 plus cosine of x. All right, from here, we've set ourselves up that we have dy dx multiplied by this big set of parentheses. If we want to get rid of that, we're going to divide by 1 minus sine of y on both sides. Okay, and we have the same factor in numerator and denominator. That makes a 1. So really, that's going to put on the left-hand side dy dx all by itself. Or that's the same thing as y prime with different notation. And our derivative is going to be what we have over on the right-hand side, 1 plus cosine of x divided by 1 minus sine of y. So I hope this helps out as you're working on implicit differentiation. Take your time. A lot of times rewriting it from the beginning so you don't have to deal with a big fraction, and the quotient rule is very, very helpful. So I hope this helps out. Good luck.